Good day. In this example, we will get the mean, median, mode of group data. We have a given class interval and its frequency count. First step is we get the total number of samples, n. It is equal to 145 by getting the sum of the f column. Next, we will create another column which is called x midpoint or the class mark. We will get the average of class intervals, 70 plus 75 divided by 2, that is 72.5. Next row, 76 plus 81 divided by 2, and that is 78.5. Next, we will do the rest of the rows. Next, we will create another column called fx. We will just multiply the f column to the x column. So 2 multiplied by 72.5 will give us 145. 7 multiplied by 78.5 will get us 549.5, and do the rest of the rows. The total is 14,082.50. Next, we get the less than cumulative frequency column. The step here is we just copy the first frequency, 2, and then 2 plus 7, 9, 9 plus 20, 29, and do that to the rest of the rows. Make sure that the last number of the less than cumulative frequency is the same with the number of samples. Now we will get the mean. X bar is equals to the summation of fx divided by n. Summation of fx is 14,082.50 divided by the number of samples, n, 145. Therefore, our mean is equals to 97.12. Next, we get the median of the group data. Median formula is x curl is equals to lower boundary plus bracket n divided by 2 minus less than cumulative frequency before the median class divided by frequency of the median class multiplied by the class width. So we get first the lower class boundary of the median class, referring to our table. Take note of the formula n divided by 2. N is 145 divided by 2 will give us 72.5. 72.5 is located here in the less than cumulative frequency between the 51st and the 89th number. We will choose the next higher interval, which is 89. Therefore, this is the median class. We will get its lower boundary by subtracting 0.5. 94 minus 0.5 is 93.5. This will be our lower boundary. Plus n is 145 divided by 2 minus the less than cumulative frequency before the median class. The less than frequency before the median class is 50. This is the median class, and the cumulative frequency before the median class is 50. Divided by the frequency of the median class. The frequency of the median class is, this is the median class, it is 39. Then we multiply it with the class width. The class width is you count 94, 95, 96, 97, 98, 99. So we have 6 as our class width. Computing this, we will get 96.96 as our median. Next, we compute for mode. Formula for mode without ties is x hat or x caret is equals to lower boundary plus d sub 1 over d sub 1 plus d sub 2 multiplied by I. So next step is we get the modal class. The modal class is the highest frequency. In this column, we can see that 39 is the highest frequency. Therefore, this is the modal class. The lower boundary of the modal class is 94 minus 0.5, that is 93.5. Plus d sub 1 is equals to the modal class. The frequency of the modal class is 39. 39 minus the frequency before the modal class. The frequency before the modal class is 21. So we put here 21. Therefore, d sub 1 is equals to 39 minus 21, and that is 18. For d sub 2, d sub 2 is the modal class minus the frequency after the modal class. The frequency after the modal class is 27. So we put here 27. Therefore, d sub 2 is 39 minus 27. This equals to 12. Now we substitute the values here. D sub 1 is 18 divided by d sub 1, 18 plus 12. Then we have the class size as 6. Computing the mode, we will get 97.10. Take note that the formula for mode is without ties. This is applicable to class intervals whose frequency are without ties. Thank you very much.